So have you ever stopped to think about where your food actually comes from? I mean, really think about it. Not just the grocery store, but the journey it takes from a tiny seed in the ground to your dinner plate. For most of human history, that journey was powered by sheer muscle and sweat. But today, we're in the middle of an agricultural revolution, and the heroes of this story aren't people, but incredible machines. We're talking about some of the most advanced and efficient agricultural technology from all corners of the globe, doing things that would seem like science fiction just a few decades ago. These aren't your grandpa's old tractors. These are technological marvels engineered with precision to tackle some of the biggest challenges in farming. From the sprawling coconut groves of Thailand to the vast carrot fields of California, these machines are completely transforming how we harvest our crops and resources. They're making the entire process faster, way smarter, and critically more sustainable for a growing planet. It's a hidden world of genius engineering that ensures we all have food on our tables, and it's happening every single day just out of sight. So get ready, because today we're pulling back the curtain on this amazing world. We're going to dive deep into the mechanics and the genius behind 20 of the most mind-blowing harvesting machines out there. We'll see how they solve unique problems for each type of crop, from delicate berries to massive trees. This is the story of human ingenuity meeting the fundamental need to eat. And trust me, after seeing these machines in action, you'll never look at a simple carrot or a can of tomatoes the same way again. Let's get into it. Alright, let's kick things off in the beautiful tropical landscape of Thailand, a country that gives the world over 2.3 billion coconuts every single year. Now you might picture someone climbing up each individual palm tree, but that would be incredibly slow and dangerous. Instead, they've developed a deceptively simple yet brilliantly effective tool, an extremely long pole, often made of lightweight aluminum or bamboo, with a sharp curved blade at the end. It's a perfect example of how the right tool, even if it's not a multi-million-dollar machine, can revolutionize an industry. These harvesters are true masters of their craft. Standing on the ground, they maneuver these poles, which can be up to 60 feet long, with incredible precision. They hook the blade around the stem of a coconut bunch, and with a quick practice twist, send dozens of coconuts tumbling to the ground. It's a combination of physics, skill, and pure strength. They have to judge the angle, the weight of the bunch, and the force needed, all while handling a ridiculously long lever. It's a physically demanding job that requires years of practice to perfect, but it's far more efficient than any other manual method. Think about the engineering problem here. How do you get something from 60 feet up in the air, down to the ground safely and quickly, over and over again? While we'll see a lot of complex robotics today, this low-tech solution is a testament to human ingenuity. It's a system that has been refined over generations, allowing Thai farmers to meet the massive global demand for coconut water, milk, and oil. This simple pole is the backbone of an entire industry, a powerful tool that helps harvest billions of coconuts annually. Next, we're heading to the Golden State of California, which is basically the carrot capital of the United States. A staggering 85% of all carrots eaten in the United States come from right here. To pull off that kind of volume, you need some serious mechanical muscle. Enter the carrot harvester, a massive, multi-ton machine that looks like it rolled straight out of a sci-fi movie. This beast doesn't just pick carrots, it inhales them from the earth in a continuous, unbelievably efficient process that is mesmerizing to watch. Here's how it works. As the harvester moves along the rows, a set of rotating rubber belts grabs the green leafy tops of the carrots. At the exact same moment, a blade-like plow called a lifter share runs deep under the soil, loosening the carrots from the earth. This precise timing is key. The belts then pull the now loosened carrots straight up out of the ground and onto a conveyor system inside the machine. It's a perfectly synchronized mechanical ballet happening at high speed. Once inside, the magic continues. The machine automatically slices off the green tops, which are then ejected back onto the field to act as natural fertilizer for the next crop. The carrots themselves continue on a series of conveyors where they are sorted and collected in a massive hopper. When the hopper is full, it unloads the thousands of pounds of carrots into a truck driving alongside it without ever stopping. This high-capacity system is what allows California to dominate the carrot market, harvesting entire fields in a matter of hours. Sticking around in California, let's talk about another green vegetable that dominates the produce aisle: broccoli. An incredible 90% of the broccoli in the United States is grown here. And just like with carrots, that level of production is only possible thanks to some specialized and seriously impressive machinery. The challenge with broccoli is that not all the heads in a field mature at the same time. You can't just clear-cut the whole field. So, how do you build a machine that can harvest selectively and efficiently? The solution is a fascinating blend of human guidance and mechanical power. The broccoli harvester is a wide, platform-like machine that spans multiple rows at once. On this platform, a team of workers lies on padded boards, facing down, hovering just above the broccoli plants as the machine slowly moves forward. This might look a bit strange, but it's an ergonomic solution that allows workers to comfortably and quickly identify and harvest only the mature heads of broccoli. It's like a mobile, human-powered sorting system. As the workers spot a ready head of broccoli, they cut it with a small knife and place it onto a central conveyor belt running down the middle of the machine. This belt then carries the broccoli up into a hopper or directly to a sorting and packing station right on the harvester itself. This immediate processing preserves the freshness of the vegetable. This machine is a perfect example of collaborative robotics, where the machine does the heavy lifting, moving the platform, conveying the product, while humans handle the delicate task of selection, a job that is still too complex for most AI. Okay, let's move on to another staple of the salad bar, celery. And you guessed it, we're still in California, which along with states like Michigan and Florida, helps produce about 80% of the celery in the United States. Harvesting celery is tough work. It grows low to the ground and has to be cut precisely at the base. Doing this by hand is backbreaking and slow. So, engineers developed a celery harvester that automates this process with brutal efficiency. This machine is an absolute unit. At the front, it has a set of guides that funnel the celery stalks towards a pair of high-speed circular saw blades, positioned just at ground level. These blades spin at thousands of RPM and slice through the base of the celery stalks with surgical precision. At the same time, a paddle wheel or a set of soft belts grabs the tops of the stalks, guiding them onto a conveyor system. The coordination has to be perfect to ensure a clean cut without damaging the product. Once on the conveyor, the celery travels up into the main body of the harvester. Here, it's often met by another set of blades that trim the leafy tops to a uniform length, making them ready for packing. Just like the other harvesters we've seen, the celery is then collected in a large bin or truck that drives alongside. This machine transforms one of the most labor-intensive harvesting jobs into a streamlined mechanical process, allowing farmers to clear acres of celery in the time it would take a manual crew to do just a few rows. Now for a fruit that we often treat as a vegetable and one that's in just about everything, the tomato. Specifically, processing tomatoes used for sauces, pastes, and ketchup. Harvesting these by hand would be impossible on the scale needed. This is where the tomato harvester comes in, and it's a masterpiece of mechanical sorting and gentle handling. The machine is designed to harvest thousands of pounds of tomatoes per minute while minimizing bruising and damage. The process starts with a set of sharp discs or a blade at the front that cuts the tomato plant at its base, scooping up the entire plant, vines, leaves, and all, onto a wide conveyor belt. This whole mess is then carried up into the heart of the machine. This is where the real genius is. The plants are fed into a mechanical shaker system. This is a series of vibrating rods and belts that shake vigorously, causing the ripe tomatoes to detach from the vines and fall through onto a separate conveyor below. But now you have a mix of tomatoes, dirt clods, and stray leaves. So the tomatoes pass through a series of sorting stages. High-powered fans blow away the lighter leaves and debris. Then they often roll onto an electronic color sorter. This is incredible tech. High-speed cameras identify anything that isn't a perfect ripe red tomato, like green tomatoes or dirt clods, and triggers tiny jets of air that puff the unwanted objects off the conveyor belt, leaving only the good stuff. It's a high-tech quality control system operating at blinding speed. Let's talk about a leafy vegetable that's a staple in cuisines all over the world: cabbage. Harvesting cabbage heads, which can be heavy and are nestled close to the ground, is another physically demanding task. To automate this, engineers have created specialized cabbage harvesters that are both powerful and precise. These machines are designed to scoop up the cabbage heads cleanly, without damaging the tightly packed leaves, which is the key challenge. The front of a cabbage harvester features a unique intake system. It often has a torpedo-shaped snout that slides under the cabbage head, lifting it slightly. As the head is lifted, a pair of sharp horizontal cutting discs, similar to what we saw with celery, slices the stem at the base. Immediately after the cut, two soft, counter-rotating belts grip the cabbage head on either side, gently but firmly lifting it from the ground and carrying it up an inclined conveyor. The grip has to be just right. Too loose and you drop it, too tight and you crush it. Once on the main conveyor, the cabbage heads are transported to the back of the machine. Depending on the model, they might be inspected by workers who remove any damaged outer leaves before the heads are deposited into a large storage bin. This process allows for a continuous harvest, moving through the field at a steady pace. It's another example of a purpose-built machine designed to solve a very specific agricultural problem, turning a tedious manual task into a highly efficient, automated operation. Now for something a bit more delicate: scallions or green onions. These are slender, fragile, and, well, they grow in these dense clumps. Pulling them out of the ground without breaking them is a challenge, honestly. The scallion harvester is a highly specialized piece of equipment that demonstrates an incredible level of mechanical finesse. It has to be gentle enough not to snap the green stalks, but strong enough to pull the bulbs from the soil. The harvester operates using a clever clamping and lifting mechanism. As it moves over a row of scallions, a pair of soft, parallel belts converges to gently clamp onto the green tops of the plants. Just as the belts grip the scallions, a vibrating plow or share runs underneath the soil to loosen the root bulbs. The belts then lift the entire clump of scallions straight up and out of the ground. The vibration is crucial. It shakes off most of the excess soil from the roots right at the moment of extraction. After being lifted, the scallions are transported up a conveyor, still clamped by their tops. They are often carried past a trimming system that neatly cuts the roots and sometimes the very tips of the green leaves to create a uniform product. Finally, they are collected in bunches and placed in crates by workers stationed on the harvester. This machine combines multiple steps: lifting, cleaning, trimming, and bunching into one smooth, continuous motion, showcasing a remarkable level of specialized engineering for a delicate crop. Let's dig into a crop that's essential for adding flavor to dishes worldwide: garlic. Harvesting garlic involves pulling the bulbs from the ground and then curing them, and modern equipment has streamlined this process significantly. The garlic harvester is built to be robust, as it has to deal with digging into compacted soil to retrieve the bulbs without smashing them to bits. It's a task that requires a balance of force and care. The process begins with a digging share, a strong blade-like plow at the front of the machine that delves into the soil beneath the garlic bulbs. This share lifts the entire garlic plant, along with a chunk of soil, onto a vibrating conveyor web. This is the first cleaning stage. The vibration of the web causes the loose soil and small rocks to fall through the gaps, leaving the garlic plants on top. It's a simple but highly effective method of separating the product from the dirt. As the garlic plants travel further into the machine, they are often topped. A set of blades cuts off the long green stalks, which can be used for other purposes or left on the field. The remaining bulbs continue on another conveyor for further cleaning and sorting before being deposited into a large bin. Some advanced harvesters even have brushing systems to remove any remaining dirt. This mechanization allows farmers to harvest vast fields of garlic quickly, ensuring a steady supply for everything from garlic bread to fancy cuisine. Let's switch from vegetables to fruits, starting with the sweet, delicious cherry. Cherries for processing, the ones you find in pies, jams, and maraschinos, are harvested in a way that is both incredibly violent and surprisingly effective. Instead of picking each cherry one by one, farmers use a mechanical tree shaker. This thing is exactly what it sounds like: a machine designed to literally shake the fruit right off the tree. The cherry harvester is typically a two-part machine. First, a large, inverted, umbrella-like canvas is spread out around the base of the cherry tree to catch the falling fruit. Then, the second part of the machine, the shaker, moves in. It has a powerful, hydraulically powered clamp that grabs onto the trunk of the tree. Once secured, the operator activates the clamp, which begins to vibrate the tree at a specific high frequency. This violent shaking is enough to dislodge the ripe cherries from their stems. Within seconds, a rain of red cherries pours down from the branches, landing safely on the canvas below. The canvas then funnels the cherries onto a conveyor belt. On this conveyor, a massive fan generates a powerful updraft. This blows away any leaves, twigs, and other debris that fell with the fruit, a process called destemming and cleaning. The clean cherries are then collected in bins filled with water to cushion their fall and prevent bruising. It's a brute force method, but it can clear an entire orchard in a fraction of the time it would take to hand pick. So, the same brilliant shaking technology we just saw with cherries is also used for another major fruit crop, citrus. Oranges, lemons, and grapefruits, especially those destined for juice, are often harvested using similar mechanical shakers. Now, given the size and weight of citrus trees, these machines have to be, honestly, incredibly powerful and robust. The goal is the same as before: get the fruit off the tree and into a bin as fast as humanly or mechanically possible. There are actually a few different designs for citrus harvesters. Some use a large single-arm shaker that clamps onto the trunk, just like the cherry harvester. Others use what's called a canopy shaker design, which is this massive machine that drives over the entire row of trees. This type has a series of rotating tines or paddles that reach into the tree's canopy and shake the branches directly. This method can be even faster for the densely planted trees you'll find in modern orchards. Regardless of the shaking method, the collection system is key. Large catch frames, often on two separate vehicles on either side of the tree row, are positioned to catch the falling fruit. These frames are padded and designed to gently funnel the oranges or lemons onto conveyors. Just like with cherries, high-powered fans are used to blow away leaves and debris before the fruit is collected. This technology is absolutely essential for the massive juice industry, enabling the harvest of millions of tons of citrus needed to fill all those cartons of OJ. Now for something completely different. We're moving from farms to forests to look at one of the most powerful and complex pieces of heavy machinery in the world, the timber harvester. This single machine can do the work of an entire logging crew, and it does it with, honestly, terrifying speed and precision. A timber harvester is designed to grab a tree, cut it down, delimit, and slice it into predefined lengths, all in a matter of seconds. The business end of this machine is the harvesting head, a multifunctional marvel of hydraulic engineering attached to a crane-like boom. The operator uses the boom to position the head at the base of a tree. Two powerful grab arms clamp onto the trunk. Then a high-speed chainsaw, integrated right into the head, swings out and fells the tree in a single clean cut. But it doesn't just drop the tree, the machine actually holds onto it, maintaining complete control. With the tree now held horizontally, the real show begins. The operator activates a set of feed rollers on the harvesting head. These rollers pull the entire tree trunk through the head at high speed. As it passes through, a set of sharp, curved, delimbing knives automatically close around the trunk, stripping off all the branches in a flash. At the same time, a sensor measures the length of the trunk as it passes through. The onboard computer then tells the chainsaw to cut the trunk into perfectly measured, pre-programmed logs. It's really a one-stop shop for processing trees. Back to the fields, let's look at a crop that requires a much gentler touch: spinach. When you buy a bag of baby spinach, you want tender, undamaged leaves. Harvesting this delicate crop by hand is, well, pretty tedious. The spinach harvester is engineered to slice and gather these leaves quickly and cleanly, ensuring they get from the field to your salad bowl in peak condition. The key here is precision cutting and gentle handling. The spinach harvester is a wide machine that covers multiple rows at once. At the front, it's got a very long, sharp, bandsaw-like blade that runs horizontally, just above the soil. The height of this blade is precisely adjustable, allowing the operator to cut the spinach leaves at the perfect point, leaving the roots in the ground to potentially regrow for a second harvest. This clean, swift cut is absolutely essential to prevent bruising and tearing of the delicate leaves. As the leaves are cut, a gentle reel or a current of air from a fan lifts them off the ground and guides them onto a soft mesh conveyor belt. This belt carries the leaves up into the machine where they are collected in large, ventilated bins. The mesh conveyor allows dirt and small debris to fall away during transport. The entire system is designed to minimize impact and preserve the quality of the leaves. It's a high-speed, high-precision operation that ensures the tenderness of the final product. Let's talk about harvesting, not for humans, but for livestock. Hay is a critical food source for cattle, horses, and other farm animals, and harvesting it is a multi-step process that has been perfected by a series of specialized machines. It's not just one machine, but really a team of them that work in sequence to turn a field of grass or alfalfa into nutritious hay bales. It starts with cutting. First, a machine called a mower conditioner, or a windrower, cuts the crop. It uses a series of high-speed rotating discs, or a sickle bar, to slice the grass at the base. Immediately after cutting, the crop passes through a set of rollers that crimp or condition the stems. This is a crucial step. By cracking the waxy outer layer of the stem, it allows the moisture inside to evaporate much more quickly, which speeds up the drying process significantly. The machine then lays the cut crop down in neat rows called windrows. After a few days of drying in the sun, a machine called a hay rake comes through. It gently sweeps several windrows together into one larger, fluffier row, which ensures even drying and makes collection more efficient. Finally, the baler comes to do the grand finale. The baler picks up the dried hay from the windrow, compresses it under immense pressure into a dense block, and then automatically wraps it with twine or net wrap to create the familiar hay bale, either a small square one or those giant round ones you see in fields. Strawberries are one of the toughest challenges for agricultural automation. They are incredibly delicate, they hide under leaves, and they ripen at different times, requiring selective picking. For decades, a reliable robotic strawberry picker seemed like science fiction. But now, with advances in AI, computer vision, and robotics, it's becoming a reality. These robots are at the cutting edge of ag-tech. These machines are autonomous rovers that navigate the strawberry rows using GPS and LiDAR. They are equipped with multiple robotic arms, and at the end of each arm is a sophisticated gripper. But the real magic is in the vision system. High-resolution cameras, often using multiple spectra of light, scan the plants. An AI algorithm processes these images in real time to identify strawberries, determine their exact location, and, this is the hard part, assess their ripeness based on color, size, and even glossiness. Once a ripe strawberry is identified, the robot's brain calculates the perfect trajectory for the arm to reach it without disturbing the rest of the plant. The gripper, which might use soft silicone fingers or a gentle suction cup, approaches the strawberry, snips the stem with a tiny cutter, and carefully places it into a punnet. The robot can even sort the berries by quality as it picks. These machines can work 24/7, rain or shine, solving labor shortages and picking with a consistency that humans just can't match. If strawberries are delicate, raspberries are on a whole other level. They can practically turn to mush just by looking at them wrong, so how on earth do you harvest them with a machine? The solution is ingenious and, like the cherry harvester, relies on shaking. But it's a much gentler shake. Raspberry harvesters are tall, over-the-row machines that you drive over a row of raspberry canes. Inside the machine's tunnel-like structure are sets of long, rotating spindles with soft, flexible fingers or rods. As the machine moves forward, these spindles spin next to the raspberry canes, and the soft fingers gently tap and shake the branches. The vibration is carefully calibrated to be just strong enough to dislodge the perfectly ripe raspberries, which detach easily, while leaving the unripe greener ones still attached to the plant for a future harvest. As the ripe raspberries fall, they land on a series of catch plates and soft conveyor belts positioned below. These conveyors are designed to cushion the fall and minimize any impact. A system of air blowers is also used to remove any leaves, small insects, or other debris that may have fallen with the berries. The clean, delicate raspberries are then transported into collection trays or flats. It's a remarkably gentle system for such a large machine, making the commercial raspberry industry possible. Okay, this next one is a bit different and not for the squeamish, but it's a critical part of making sure nothing from an animal goes to waste. We're talking about the cattle hide harvester. After an animal is processed for meat, the hide is a valuable co-product used to make leather for shoes, belts, car seats, and more. Removing the hide manually is difficult, time-consuming, and requires immense skill. Modern processing plants use a mechanical system to do this efficiently and cleanly. This process, often called hide pulling or hide stripping, involves a powerful machine. The animal is typically hoisted by its hind legs. A few initial cuts are made by skilled workers to free up the edges of the hide around the legs and belly. Then, a heavy-duty clamp from the hide puller is attached to the skin at the neck. The machine is then activated, and a powerful winch or hydraulic system begins to pull the hide downwards, essentially peeling it off the carcass in one single piece. The machine has to apply a tremendous amount of force, but it also has to be controlled to prevent tearing the hide or damaging the underlying meat. Modern systems use sensors and variable speed controls to adjust the pulling force throughout the process. It's a stark and industrial process, but it's a crucial step in the supply chain. This automation ensures that a valuable resource is preserved with maximum efficiency, reducing waste and providing the raw material for the global leather industry. From land to sea, let's look at how technology is revolutionizing aquaculture with the salmon harvester. In large-scale salmon farms, which you see in places like Norway and Chile, harvesting thousands of fish efficiently and humanely is a major logistical challenge. Automated systems have been developed to streamline this entire process, from getting the fish out of their sea pens to preparing them for processing. The process often starts with a crowding system, where a net within the sea pen is slowly raised, concentrating the salmon in one area. From here, a large pipe connected to a vacuum pump is lowered into the water. This system, sometimes called a fish pump, gently sucks the salmon and seawater out of the pen and onto a harvesting vessel or a shoreside facility. This method is much less stressful for the fish than being caught in nets and hoisted out of the water. Once on the vessel or in the facility, the salmon are transported in channels of flowing water to an automated processing line. Here, machines can stun, bleed, gut, and even fillet the fish with incredible speed and precision. Computer vision systems can grade the fish by size and quality, directing them to different processing lines. This level of automation not only boosts productivity immensely, but also improves food safety and product consistency, helping to meet the massive global demand for this popular fish. Let's get back to the orchard for one of the world's most popular fruits, the apple. While many apples for the fresh market are still hand-picked to avoid bruising, the industry is rapidly moving towards automation, especially for apples destined for juice, sauce, or cider. These apple harvesters are designed for high-capacity work, clearing trees with impressive speed and efficiency, and they're becoming more and more gentle. Some of the most innovative apple harvesters are platform-based. These are multi-level machines that allow a team of workers to be positioned at different heights within the tree's canopy. Instead of climbing ladders, workers can simply pick apples and place them on soft conveyor belts right next to them. This is safer and much faster than the traditional bag and ladder method. It's a human-machine collaboration that increases efficiency dramatically. But the real futuristic tech is the vacuum harvester. This machine works alongside a tree shaker. After the shaker dislodges the apples, they fall onto a catch frame. From there, instead of conveyors, large soft-mouthed vacuum tubes gently suck the apples up. The air pressure is carefully controlled to lift the apples without bruising them. They are then transported through the tubes into a large bin. This technology is still evolving, but it points to a future where even fresh market apples can be harvested mechanically without damage. You might not think about it much, but a huge portion of the world's sugar doesn't come from sugarcane. It comes from sugar beets. These are large root vegetables that look like a pale, oversized turnip. Harvesting them is a tough job that requires digging them up from the soil, cleaning them, and topping them. To handle this, farmers use enormous self-propelled sugar beet harvesters that are some of the biggest and most complex machines in agriculture. These machines perform multiple tasks in a single pass. At the very front, a set of rotating flails shreds the leafy green tops off the beets. Right behind the flails, a topping unit with precise sensors and blades cuts the very crown off each beet, as this part is low in sugar. Then comes the main event, the lifting shares. These are rotating wheels or plows that dig deep into the soil and gently lift the beets out of the ground. Once lifted, the beets travel through a massive internal cleaning system, often involving a series of rotating turbines or webs. These star-shaped wheels tumble the beets, causing dirt and mud to break off and fall away, while being gentle enough not to damage the beets themselves. Finally, a long conveyor arm transports the clean beets into a massive onboard hopper. When full, this hopper can unload into a truck in just a minute or two. These machines are absolute monsters of efficiency. Last but not least, let's dig up a favorite snack, the peanut. A fun fact is that peanuts don't grow on trees, they grow underground. This makes harvesting them a unique two-step process. First, a machine called a digger inverter goes through the field. It has a long blade that cuts the main root of the plant below the peanuts and lifts the entire plant from the soil. Then, it gently shakes the excess dirt off and flips the plant over, leaving it on the ground with the peanuts facing up to dry in the sun for a few days. After the peanuts have dried, the second machine, the peanut combine or harvester, comes in. This machine is the star of the show. It uses a rotating pickup mechanism at the front to gather the dried plants from the ground. The plants are then fed into a threshing mechanism inside the combine. This is where the real separation happens. The thresher, through a combination of rotating bars and grates, strips the peanut pods from the vines. The separated peanuts fall onto a series of shaker pans and are subjected to high-powered fans. This is the cleaning process, which removes any remaining dirt, leaves and vine pieces. The clean peanut pods are then collected in a large basket on top of the machine. The leftover vines and leaves are chopped up and ejected out the back, returning nutrients to the soil. It's a clever, multi-stage process, all contained within one machine, ensuring our supply of peanut butter remains uninterrupted. So there you have it, 20 incredible machines that are the unsung heroes of our global food supply. From the simple genius of a coconut pole to the complex AI of a strawberry-picking robot, the level of engineering and problem-solving on display is just staggering. These machines are doing more than just saving time. They are fundamentally changing the equation of farming. By drastically reducing the need for strenuous manual labor, they are making farming a more sustainable and productive profession for people all over the world. Think about the impact. These agricultural marvels are boosting productivity to levels that were unimaginable a century ago. They allow us to harvest more food from less land, which is absolutely critical as our global population continues to grow. They ensure consistency, improve food safety, and reduce waste, helping to sustain the complex supply chains that feed billions of people every single day. This isn't just about cool technology, it's about tackling one of humanity's greatest challenges, ensuring there's enough food for everyone. This is the cutting edge of an industry that affects every single one of us, and it's constantly evolving. It makes you wonder what the farms of the future will look like. What did you think? Which one of these machines completely blew your mind? Was it the brute force of the timber harvester, or the delicate touch of the raspberry picker? Let me know in the comments below. And if you love seeing how amazing technology and engineering are shaping our world, make sure you hit that subscribe button and ring the bell so you don't miss the next adventure. Thanks for watching. Thanks for